Hello, my dear students. It's my pleasure to meet you again. I am Mr. Naasir and my colleagues behind cameras. My greetings to you. Today, inshallah, we are going to study new lesson, which is trig lesson, which is directed angle. What is a directed angle? You know about the angles from the previous studying that we have an angle here. If we have angle like that, we say this is the angle A, B, C, or X, Y, Z, or Y, Z, X, anyway. But now we will study a directed angle. The word directed means it's the direction. So if we have two rays, then this ray here will be initial side, and this ray here, the terminal side, will move in this side or direction. So the angle here will be positive because it's in anti-clockwise direction. And if we consider this one initial, then this side is a terminal and the movement on the clockwise, and it will be negative. So the difference is the direction here. Directed angle is different from the angle by direction. So let's move to here to draw. If we have an angle here like that, this is a side. We have here A as example, B, C. Okay. We have an angle here. This angle, we say that the angle CBA or ABC as the previous studying. But now we will consider about initial side. If we consider this one is initial side, and this side will be terminal side. Initial side means starting side, and this one means ending side or end side. Okay, then we have an angle considered directed angle because this is the starting and we move in that way or this direction. So this angle will move from here to here, and this is the initial side and this is the terminal side, and the direction here will be on or anti-clockwise direction. Anti-clockwise direction means positive. Anti-clockwise. Okay. So this angle will be positive. If it is anti-clockwise direction, it will be positive. As example, 60 degrees, 70 degrees will be positive here, and so on. Okay. But if we have another angle like that, we have an angle here, two rays or two sides, and we have here A, B, C, and if we consider that this side will be initial and this side will be terminal, the direction of course will be starting from here to here. This is the direction, and the whole direction will be on clockwise direction, on clockwise direction. So the angle will be negative. If this angle 70, it will be negative 70 degrees. Okay, we can say negative 70 degrees, negative 80 degrees, and so on. So we have seen that the difference between the just angle or direct angle here, the directed angle has the two sides, one of them initial and the other terminal, or this one is initial and this one terminal. The angle starting from initial to terminal like that, and if it is in that direction, it will be anti-clockwise direction, and of course it will be positive. And if it is in this direction, so it is on clockwise direction, so the angle will be negative. Okay, let's move to another point. Okay. Okay, we have the reordered pair. If we have this angle like that, and as we said, here is initial and this one is terminal. Okay, so if we call this angle A, B, C, and this is direction, AB is initial and EC is terminal. Okay, so we will call this angle as an ordered pair starting from BA and ending with BC. So directed angle now, we can define it or call it as an ordered pair here. BA is the initial side and BC is terminal side. And concentrate about that the ordered pair BA and BC doesn't equal the ordered pair BC and BA. Why? Because the ordered pair BA and BC means that BA is initial here and BC is terminal, so the angle makes this direction, so the angle is positive because it is anti-clockwise direction. But if we have another angle like that, it is obtuse angle A, B, C. Okay, say that A and this is C to be the same name, and we have here the ordered pair BC and BA. That means that BC is the initial side and BA is the terminal side. So this angle will be negative, say negative 120 degrees, because it is anti-clockwise direction. Okay, so it's very important to notice that the ordered pair, the beginning side here means the initial, and terminal side means terminal, and this is the direction of it. But here BC and BA, we're starting with BC and ending with BA, so direction here is this direction. It will be negative because it is on clockwise direction. Okay, let's move to another point. Just a second. We have here an angle. This angle has positive measure and negative measure. Okay, if we have an angle like that, the other side, we have an angle XYZ like that. If this angle will be 110 degrees, 110 degrees because it takes anti-clockwise direction here. Okay, the direction will be anti-clockwise direction like this, so it will be this direction. Okay, this is the positive angle. The positive angle has another negative angle, okay, like that. We get it by subtracting from 360, because we know that the cumulative angle is about a point here, as a circle here, equals 360. So to get the negative angle of 110, we will add negative 360 plus 110, okay, by subtracting here. 0 from 0 equals 0, 1 from 6 equals 5, 1 from 3 equals 2, and the answer will be negative. So the negative angle of the angle 110 equal negative 250 angles, because it is on clockwise direction. And also we can find the positive angle of another negative angle like that. If we have an angle like this angle, and we have here negative 50 angle, so the positive angle of this angle will be take this direction, and it will have of measure the remainder of 360. So we put 360 minus 50, and the answer will be 310 degrees. So this is the angle negative 50 degrees. Its positive angle will be 310 degrees. We have talking about positive or negative angle. We will now move to another point. Yes. If we have the measure of directed angle 90 as this angle, if we have this angle like that, this angle x, y, z, and this is 90 degrees. Okay, to get its negative angle here will be do what? Negative 360 plus 90, and the answer will be negative 270 degrees. But if we have negative angle here, negative 90, and we want to find its positive angle, so we calculate negative 90 plus 360, and the answer will be 270 degrees as positive angle. Okay. Third thing, let's move to another point. We have many things to do. Third point is the standard position, standard position of a directed angle. What is the standard position of directed angle? We know about x, y coordinates like that. If we have x-axis and we have also y-axis like that, here is x, x dash or x negative, here is y and y dash. This is the positive direction of x-axis, and this is the negative direction of x-axis. This is the positive direction of y-axis, and this is the negative direction of y-axis. And we call this O. O is the origin point. which is the intersection point between x-axis and y-axis. Okay? So, if the angle, its vertex is the origin point, it's the first condition, and its initial side will be the positive direction of x-axis, like that, and the terminal side, any side here, like that, or like that, or like that. It doesn't matter where the terminal side lie, but the very important thing that where is the vertex, which is the origin point, where is the initial side, which is the positive direction of x-axis. So this angle in the standard position, this angle in the standard position, this angle also in the standard position, and we can say that this angle here in the standard position. Notice carefully that the vertex angle again is the origin point, and the initial side will be the positive direction of x-axis. Okay? Let's move to some exercises here on this part to differentiate between any angle and directed angle in the position directed angle. Okay? If we have an exercise here like that, this is the y-axis and this is x-axis here. Okay. We have here x-axis, this is x dash, y and y dash, and we will draw many angles. Say that O, A, B, C, okay, that will be OD, and that will be OE, okay, and we have many of ordered pairs expressing some directed angles, like the angle AB and AC. What about this ordered pair? Is the ordered pair in its standard position or not? Okay, we will move to the angle AB and AC. This is the angle. We have two conditions to be in the standard position for the directed angle. The first, its vertex must be the origin point. Is this angle, its vertex here, is the origin point? No. So this ordered pair is not expressing a directed angle in its position direction. Okay? So this angle is not in the standard position. Let's move to another angle here. If we have an angle like that, the angle OB and OD, is it in standard position? Of course, yes. Why? Because we see here that this vertex is the origin point and the starting side or the initial side is the positive direction of x-axis, so it is in standard position. Let's move to another ordered pair here. OD and OE. What about OE, OD? OD here is a starting or it is the initial side, and OE is the terminal side. We have the vertex of origin point, but the initial side here is not the positive direction of x-axis, so it is not in standard position. Look also for this angle, OB, OL, OB and OL. OB here is the positive direction of x-axis, and OL here is the terminal side, and its vertex here is the origin point, so it's also in the standard position, because the starting point here, the starting side or the initial side is the positive direction of x-axis, and the vertex here is the origin point. It doesn't matter that the angle negative or positive. The angle here will be negative because it is in the clockwise direction, but it doesn't matter because we have the two conditions here, which is the vertex angle and the initial side is the positive direction of x-axis. Okay, another angle, last one, OB and OE. OB, OE here, look carefully for this angle. The initial side is the positive direction of x-axis, and the vertex of the angle is the origin point, so it is in the standard position. Okay, it's very important to practice on this. Many exams get this exercise. Sorry. Okay, we have now 3 points. We studied about what is the difference between angle and directed angle, which makes an direction here like that, and we can say direction here like that. Okay, and we talk about the position, the standard position of the angle. It must be x-axis, and this is the origin point of the vertex. So let's move about fourth point, which is equivalent angles. What about equivalent directed angles here? If we have x-axis and y-axis like that, we have here x, x dash, y, y dash, and we have this is the origin point, and say this angle is 60 degrees angle. Is 60 degrees. What about 60 degrees? Is any other angle is equivalent to this angle, which is 60? And what is the definition of equivalent angle for this angle? And how many angles are equivalent to this angle? This angle here, 60, starting from this point, and its terminal side is OB like that. Okay, we have initial side is OX, so the angle will be XOB, and its order pair is OX and OB. Okay, look carefully with me. If we have another angle starting from this point here, this initial side, and move a complete round until it comes to the same terminal side here, which is OB. What's the measure of this angle? This angle, look carefully with me, this is the complete turn to here, it will be 360, plus this part, which is 60 angle. So this angle will be 420 degrees. Okay, is the angle 420 degrees equivalent to this angle, which is 60? Yes, it is the equivalent angle. Why? Because it starts from the same initial side and move to return to the same terminal side for this angle. So this angle, which is 420, is quite equivalent to the angle 60 degrees. Okay, let's move to another one. If we have an angle here and we start from this initial side and we'll move one turn, then we will move another turn and return back to the same terminal side here and stop. So we have two turns, 360 plus 360 plus 60. Okay, so 720 plus 60 equals 780 degrees, and so this angle 780 is equivalent to the 60 degrees. Okay, so my dear students, let's take a little break and we will return again soon. Again, my dear students of first secondary schools, we will return again to study equivalent angles of directed angles. Let's concentrate here. If we have x, y coordinates here like that, this is x-axis and this is y-axis, and this is the origin point, and we have an angle, say 60, as we said before. We talk about the equivalent angles to this angle, and we said that if we have the same starting or initial side and we move 1 or 2 or 3 or more rounds, and we will return again to the same terminal side. Okay, we start with 60 plus 360 and 60 plus double 360 if we have two turns, 2 times 360, and we have also 60 plus 2 3 times 360 if we have 3 rounds, and 60 plus 4 multiplied by 360 if we have 4 turns, and so on until we have 60 plus n multiplied by 360 degrees. We know that each turn, complete turn, has 360 degrees. In here will belongs to z positive. Z positive is 1, 2, 3, 4, and so on. So if it is 1, so it is 1 turn only. If n it's equal to, we have 2 turns. If n equal 5, so we have 5 turns. Okay, this is the rule of what? Of how many or all the angles that equivalent to the angle 60. So how many equivalent angles? Of course, it's an infinite number of equivalent angles for this angle or for any angle. So we have 60 plus, or the angle theta, if this angle called theta, not only 60, it will be theta plus n multiplied by 360. It will be all equivalent angles to the theta angle here if we consider that this angle is theta. Is it only plus or positive in this direction, anti-clockwise direction? Of course not. Let's move to another point. If we have here x-axis and y-axis, like the exceed, here is y-axis, and this is the x-axis here, y dash, and we have an angle starting with the x-axis here, and this is the origin point O, and this angle will be, as example, negative 30. Okay, is it has an angles or equivalent angles? Of course, if we start here and go one round and return to the same terminal side, it will be 360, and if we complete another turn and return again to the terminal side, it's 2 turns, and if we complete here and so on. So we can say negative 30 or any angle. Here is minus. Why is minus here? Because we move in clockwise direction. In clockwise direction here means negative. So here minus n times 360, okay, or if we say theta, or even this angle, someone say it is negative, so all angles equivalent negative. No, if we have an angle here, say phi, this is some names, phi, if we have phi here, and we go to one turn and return again to the terminal side, it will be negative also. So we can theta minus n multiplied by 360 degrees, or as we said before, theta plus n multiplied 360. These all the angles which is equivalent to the angle theta, and we can put it at this theta plus or minus n times 360, okay, and all these angles are equivalent to the angle theta, or the phi angle here, it will be phi plus or minus 300 n times 360 if we talk about this angle phi. And now we have n, of course, belongs to z positive. Z positive means that n equals 1, 2, 3, 4, and so on. No negative here and no 0. Okay, so even it's 0, we can say z positive only, because 0 multiplies 160, it means that no turns, and it's phi itself, and it is already equivalent to itself, of course. But if we talk about other angles, of course we will talk about n belongs to z positive, because it if we have 0 here, it gives the angle itself. So we have infinite number of angles equivalent to a given directed angle. Okay, let's move to some exercise here. We have an exercise. Determine the smallest positive angle determines the smallest positive angle which is equivalent to number 1, the angle negative 60. We now try to find the smallest positive angle which is equivalent to 60. To get that, we write negative 60 plus 360, because we try to find the positive angle. So we will add a complete turn in the positive direction, anti-clockwise direction, so it will be plus 360. And the answer, of course, equals 300 degrees. So the smallest positive angle which is equivalent to negative 60 equal 300 degrees. Number 2, if we have negative 200, the same thing, we will add negative 200 plus 360, and the answer, of course, equals 160 degrees. Okay. If we have something like that, 780. 780 here is more than any acute angle or more than 360. So we will try minus 360 first, and the answer here will be 0. 6 from 8 equal 2, 3 from 7 equal 4. Still more than 360, so we will omit another 360 or another term, and the answer will be here 60. Okay, so the smallest angle equivalent to the angle, the smallest positive angle equivalent to 780 equals 60 degrees, because we take these turns 360 and 360 off. Okay, let's move to another question here. If we have negative 800 and we would like to find the smallest positive angle which is equivalent to negative 800, we try to add 360 and add another one because it's more than 720, and we have two turns in the positive direction here to get what? To get 280 degrees. Or we can say that if we have the calculation, well, 720 as two turns, okay, or two rounds. Negative 180 plus 720 equals 280. So 280 here is the smallest positive angle which is equivalent to 800. Okay. What about another exercise here? We talk about the smallest positive angle. We can talk now about the smallest negative angle which is equivalent to another angle. So let's do this exercise here. Determine the smallest negative angle which is equivalent to the given angles, which is number 1, 60 degrees. If we have an angle equal 60 degrees here, and we want to find the equivalent, the smallest negative equivalent angle to 60, so we add negative 360. That means that we add one turn in negative direction or unclockwise direction, and the answer, of course, will be negative 300. Okay, and if we have another angle as negative 1100, by adding 360s here, this is not enough because it remains more than negative 360. so we'll add another term in the positive direction, and the sum of these angles are or is 1080. Okay, and we have here negative 1100, and difference equal negative 20 degrees. So the smallest negative angle, which is equivalent to negative 1100 here, equals negative 20. What about 120 degree? If we have an angle like that and we would like to find the equivalent negative angle or the smallest negative equivalent angle for it, we add negative 360 of course, because this is a positive angle and we want a negative angle, and the smallest one. To add 120 plus negative 360, the answer of course will be negative 240 degrees. Okay, let's move to another point here, the position of the angle in the orthogonal coordinates. What is the orthogonal coordinates? It's xy coordinates. So if we have x-axis and the y-axis like that, x dash, y dash, and we have here, we divide these 360 here into 4 equal parts. From the angle 0 to 90, or between 0 and 90, we have the first quadrant. And from 90, or between 90 and 180 here, it's the second quadrant. And from 182 to 170 here, it's third quadrant. And from 270 to 360, it will be the fourth quadrant. So any angle here between 0 and 90, it will be in the first quadrant. Its position here, it lies in the first quadrant. Any angle measured between 90 and 180, it will be in second quadrant. Any angle between 180 and 270, it will be lies in the third quadrant. Any angle more than 270 and smaller than 360, of course, it will be in the fourth quadrant. As example, if we have an angle 70 degrees, where does it lie? It of course lie in the first quadrant, because it is between 0 and 90. And if we have an angle 120 degrees, 120 degrees lies here. If we draw an angle 120, it will be here. So the terminal side will be in the second quadrant. So the position of this angle, it lies in the second quadrant. If we have an angle 200, as example, 200, it will be like that here. Its terminal side is this side. So this angle lies in the third quadrant. The angle lies in a specific quadrant means that the terminal side lies in the same quadrant. And if we have 300 as example, if we draw the angle 300, look careful with me. If we start here and we have the end here, its terminal side will be here. It is 300 degree, and its terminal side lies in the fourth quadrant, so it is in the fourth quadrant. Someone asked me, what about the negative angles? The negative angle, as example here, 60 degrees, negative 60 degrees. Negative 60 degrees is the same as positive 360 degrees. Its position here in the fourth quadrant, like that. So negative 60 lies in the fourth quadrant. But we will have remaining some angles. It has not first, second, third, or fourth quadrant. We have here angles. We call them quadrat angles. What are the quadrant angles? Let's concentrate here. If we have here x-axis and y-axis, and we have an angle here, its measure equals 0, the 0 angle. Where is the 0 angle lies? Here 0, here is 90, here is 180 degrees, 270, and also here 360. This is 0, and after one turn here, it will be 360. Okay? So, what about the angle 0, the angle 90, the angle 180, the angle 270, and the angle 360? What about these angles? Is one of them in the first, second, third, fourth quadrant? No. So we call them quadrantal angles. Quadrantal angles. So when someone asks you, what about the angle 90? Is it in the first quadrant, the second quadrant, the third quadrant? No. We say that it is a quadrantal angle. And what about the angle 180? It is a quadrantal angle because it lies in x-axis itself. What about 270 angle? It lies here. So it lies in the y-axis. So it is a quadrantal angle. What about angle 360? It's here. So it is a quadrantal angle. Okay? Let's move to another exercise if we want. We have a little time, I think. So let's spend it in exercise about what is the angle, or what's the position of the angle. If we angle here 213, what is the quadrant of 216? Okay, here it is 0, 90, 180, 270, and here also 360 after one turn. Where is the 213? 213, of course, lies in this, its terminal here is this side. Okay? So, of course, it lies in the third quadrant. What about negative 70? Negative 70 lies here. Okay? So, it's fourth quadrant. And if negative makes you make mistake, you can make negative 70 plus 360. So, the answer equal 290 as positive. And 290 will be, its terminal side is the same terminal side in the fourth quadrant. Okay, we have now, my dear students, we now finished all about the directed angle. Until we meet again, my pleasure and my greetings, me, Nassar Jabir, and my colleagues in the Studio 12 in National TV. Thank you, good luck, and goodbye.